teacher and everybody. So I'm from Group 6 and today I will present you about our assignment that is the XE destructive driver detection. So first is our team member. My name is Chu Minh Duy and the other two members is Nguyễn Hạnh Phúc and Trần Công Quân. So this is our table of content. First is the introduction. The two next parts is about theoretical basis and initial experiments, and the three final parts is about system design, evaluation, and conclusion. First, as you may know, every country have their own law to force the driver, focusing on driving by law. However, many drivers doing something else when driving, so this destructive behavior easily cause crash accident, and it leads to the danger to the other people. So we have some alarming statistics. First, 1/5 car accident in the US is caused by destructive driver. Sadly, 42,500 people injured and 3,000 people killed. Final, the 80 according to Forbes Vietnam report, 87% young adults in Vietnam not concentrate on driving. So those alarming statistics rise the importance of how to detect the destructive driver. Of course, police cannot be on roads at any one time to monitor the driver, so we can take the advantage of surveillance camera system, which is very common in large cities, to build the robust computer vision system. This is thanks to the advance of machine learning and deep learning techniques. So we have the very powerful classification model. So in 2016, Safe Farm held an online casual competition to solve this task. According to solve this task, although this competition is ended, our group use this data to solve this problem by ourselves. Our group think this task is very meaningful because it can help to protect both the driver and the lion. So our assignment has some goals. First, we must survey and discover some machine learning techniques, especially in the computer vision field, and apply these techniques to build an application. So this application that can predict the destructive action by an image or a video. So this application may have some feature. First, it can receive either image or video as its input, and it can predict the destructive action belong to predetermined 10 labels with the accepted accuracy, and the time for prediction should be reasonable to apply to the real life. So this is we make a look of the data. The right picture is the sample picture, which can be appear in both the training set and test set. The left picture is about 10 labels. So each picture in the training or test set will belong exactly to one label of 10 labels in the left picture. So in the initial experience from the training set, we load the data and we return this data. So from that, we list randomly 80% to the training set and 20% to the validation set. So for the training set, we will train the model. We use the support vector machine with the polynomial or kernel in the first try. And for the validator set, we use this to test the model by compare the predicted value and the target to match the result. So the result on validation set provide a very good accuracy, which we can see is the 96%, and the confusion message so that this model work well for all labs. However, now we will look the result on the test set. So we can see the result is very terrible compared to the result on the validation set, which is now it's only 44%, and the confusion matrix will show this result is awful too. So what is our problem? So after review our design and data, we recognize three problems. First, the digital image store the data at the matrix of the value, which is called the pixel. So the neighbor pixel may have the similar value compared to the larger distant pixel. So when we return the data, that means we consider all pixel equally, and and when we flatten this data, we erase some information. So the flattened data is not a good processing technique when we deal with the image data. Next, about data, although each driver cannot be either on the test set or training set, but each driver cannot be multiple times. So there, when we randomly split it to the training set and validation set, it may have the case that one driver be in both training set and validation set, so that it violates the IID property. So the accuracy is either fast accuracy. Finally, the test set is larger than the training set, which is larger more than 4 times. So it makes our model easy to overfit. So as you can see, it is the sample data. You can see the both picture we get from the training set, but you can see it belongs exactly to the same people, but in the different action. The left side is about the talking on the phone, and the right side is about hair and makeup. So that it will illustrate our problem as I said before. So after recognize our problem, we redesign our model and let's move to the next part of our teammate. It's Phúc.
Hi, I am Phúc. Because of the problem that Minji said before, so we choose VCC16 to make a feature extraction. In this design, when we choose feature extraction with classification, in classification we use SVM. In here we use polynomial kernel and RBF kernel, and the last one is the submax. This is the VCC16 architecture. The input image has the shape of 224 by 224 by 3, and this architecture, we can see that it has 13 convolution layers with 5 pooling layers, and fully connected has 3 layers. So the output is the vector of 25,000 dimensions. The parameter of this model is about 14,700,000. This is a design when we use feature extraction with SVM polynomial kernel. The input image has a shape of 224 by 224 by 3, and this extraction model will extract the feature vector of 25,000 dimensions. And with this feature, we train with SVM. This is a formula of polynomial kernel. T is degree, R is coefficient. We use degree is 3, and we train this model 100 iterations. And the design for RBF kernel is same as polynomial kernel. This is the Taylor series, the formula of the RBF kernel. This symbol is parameter gamma, and we also train 100 iterations, and we also use submax for classification. Submax will transform the vector into the probability distribution vector. This is the formula of submax. And why submax is here? We use submax as the class layer for training VCC16. So we keep using submax as the classification. In here you can see its picture. The accuracy of training and validate. After 20 epochs, we train. The accuracy of training and validate is about 90%, and the loss of training is about 0.3, and the loss of validate is about 0.47. After I have 3 classification model with VCC16, we compare the performance with the test set. Test set consists of the driver that's different from training set. Why? Because in the data it have a metadata. In this metadata, it has the ID of driver for each folder, so we can easily separate the driver by ID. So we use testing set to test the performance of this trees model. When we use SVM polynomial kernel, it has the result is not good. You can see here, with accuracy recall and score is about 0.5457, but when we use SVM with RBF kernel, it has a result better than polynomial kernel. Its accuracy is 0.91 and a score is 0.75, and submax which we use to train with VCC16, it has accuracy is 0.89 and the score is 0.72. In the future, we will use another feature extraction like ResNet 50 or Inception to have the better feature extraction.
Hello, my name is Kwon from Group 6. Now we move on the demonstration applications of our projects. Our application is run on the QML language for the user interface and the Python language for the application logics. We choose the QML for the user interface because this language is easy to import on the embedded device, for example, on the panel, the cars. And we use the Python language for application logics because Python supports very strongly in machine learning. Some frameworks and library that we use. The QtQuick is the development framework to develop the QML user interface, and the PyQt files is to connect the Qt user interface and the Python. OpenCV is an open source library for the computer vision. We use it to process our image before detections. And TensorFlow machine learning libraries we use to apply our models for the image detections. Is the user interface of our applications. We have two modes: is video detections and image detections. If you choose the image detections, you will have two options. The first, you will press the choose image and select image you want to detect, a single image. So the applications will detect that image, or you will put all the image on a folder named test image. So and press the start button, so the application will auto detect all the image on that folder. For example, in here, the application detects that this driver is drinking. If you choose the video detection, the applications will extract the video into many frames and detect on each frames. For example, in here, the application detects that the driver on the videos is detecting on the right hand. After we do our projects, we have some conclusions and experience. First is not only the models, but also the data is very important. If we have a good analysis on the data, we can choose better models for our applications. And second is all the features should not be considered equally. Some features are very important, but some are not. So we must have some methods to reduce our dimension or reduce our features. When apply the AI into real applications, we should consider both times and accuracies. Because, for example, in our applications, if you detect the drivers too long or not accuracy, can lead to a car accident. For the future work of our project, we can apply some other classification methods like ResNet or the MobileNet. We can also improve our accuracy using assemble learnings. So the final result is the major worst of many classification models. But this method will increase the performance times. The third is we using the KNNs for the output weights. It works well in the case of video detection because we have many similar images. So we can use the pixel loss to update the weight beyond the KNN. For the application upgrade, we can in the future we can make it to detect from the real-time videos, or we will notify when driver is distracted. We can notify the drivers or through the phones or through the emails. Third, we can export because our application rely on the QML language, so we can export on the embedded device to use it on the cars, on the panel on the cars, or in somewhere else like the police stations. Thank you for watching our presentation.